So students, welcome to another lecture of structural analysis. In this lecture, we will try to uh, analyze the continuous beam shown in the figure using three-moment equation. So to do that, uh, first what we require is we require certain basic things with regard to three-moment equation. That is, we have to draw the simply supported bending moment diagram. So for this case, the simply supported bending moment diagram would be a triangle, and for this span, the simply supported bending moment diagram would be a parabola. The magnitude of this would be, the bending moment here would be WL by 4, that is WL by 4, that is 120 into 3 divided by 4, that would be 90. So this magnitude would be 90 here, and here the magnitude would be WL square divided by 8, that is 40 into 3 square divided by 8, that would come as 45 kilonewton meter. So this would be 45 kilonewton meter. So the area of this particular bending moment diagram, that is A1 will be half into 90 into 3, that would be, it would come out as 135. So A1 will be 135. Similarly, A2, the area of the uh, right bending moment diagram, that would be 2 by 3rd the area of the rectangle, that is 45 into 3. So that would come out as 90. So A2 is equal to 90. Now we have to mark X2 also. So this would be X2, that is, since it is a symmetric bending moment diagram, X2 would be equal to 1.5. Similarly, this is also a symmetric bending moment diagram, so X1 will also be 1.5, and also there is no support settlements, therefore delta 1, delta 2, delta 3 will be equal to 0. Similarly, the end supports here are both symbol supports. So this is a symbol support, so MA will be equal to 0. This is also a symbol support, so MC will be equal to 0. So the only unknown in this equation is MB, and we have to find MB. So to find MB, let us try to write the three moment. So let us try to write the three moment equation. So that is MA into L1 here is 3 divided by I plus 2MB into L1 is 3 divided by I plus L2 is also 3 divided by I plus MC into 3 divided by I is equal to minus 6 into A1 is 135 into X1 is 1.5 divided by I1 L1. I is L1 is 3 minus 6 into 90 into 1.5 divided by I into 3. So here this term would be 0 and this term also would be 0. So if we try to solve this equation, we will get this as 12 MB by I is equal to minus 6 into 225 into 1.5 divided by 3I. Solving, we get MB is equal to minus 56.25 kilonewton meter. So this is the magnitude of the support moment. Now using this, we have to draw the shear force and the bending moment diagram. So to do that, we have to analyze the beam. So let us consider the beam. Let this be RA. Let this be RB left. Let this be RB right. And let this be RC. This is 40 kilonewton per meter. This is 3 meter. And we have 120 kilonewton here. This is 1.5. This is 1.5. And the moment MB is a hogging moment. So we have to represent it as a hogging moment of magnitude 56.25. So this is 56.25. 56.25. So if we try to solve this for this particular beam, sigma m about b equal to 0. So 3RA minus 120 into 1.5 plus 56.25 equal to 0. So RA equals 41.25 kilonewton. So we can also see that RB comes out as this comes out as 78.75 kilonewton. In a similar fashion, if you solve for this particular beam, we can write this as taking moment about b equal to 0. So 3RC minus 40 into 3 square divided by 2 plus 56.25 equal to 0. So RC equal to 41.25 kilonewton and RBR is equal to 78.75 kilonewton. Now using these values, we can draw the shear force and bending moment diagrams. So to draw the shear force diagram, the magnitude of shear here is 41.25. The sign convention is like this. Sagging is assumed as positive and clockwise shear is assumed as positive. So here we have 41.25. So this would be our shear force diagram. Similarly, to draw the bending moment diagram, this is the simply supported bending moment diagram. So what we will do is, the magnitude here is 90, the magnitude here is 45. So we will superpose that with the support bending moment diagram. So this is the bending moment diagram and this is the shear force diagram. So with this we will stop this lecture and we will continue with another problem in the next lecture. Thank you.